All right, welcome back. Now, hopefully you solved the application problem already. If you didn't, stop right now. Try it. Remember, the struggle and the challenge is good for your brain. You got to give it a try. Okay, here's how I solved it. I used a tape diagram. You may have done it a different way. In fact, it might have been more efficient to solve it in a different way, but tape diagrams work and I like to use them. So here's how I solved it. So I've got my 3 tape diagrams. I have one for each person. Jamal ran 2/3, so I have his divided up into thirds, and I'm going to color in 2/3. Ming ran 2/4 of a mile, so I'm going to color in her 2/4. And Lena ran 7/12 of a mile, so I'm going to color in 7 of these 12ths. 1, 2, 3, 4, 5, 6, 7. Now here's why tape diagrams work, but aren't always maybe the most efficient. So it took me a minute to draw this, but also remember when we're drawing tape diagrams to compare, our tape diagrams have to be the same size, and we can't always get it exactly the same size. They also have to be partitioned or divided up so that each piece is exactly the same size. Again, it's really hard to draw that perfectly. So if there was a different way you solve this, it might have been even better. But from what I can see, it looks like Ming definitely didn't run as far as Lena or Jamal. And it looks like Jamal ran the furthest. Now you may have solved it a different way. If you did, hopefully we came up with the same answer, because that's one of the best ways we can check ourselves, is to compare against each other. Okay, let's move on to our lesson now. Yesterday, we were comparing some fractions and we were looking at the size of the pieces. So I'm going to show you a fraction that I know you can solve if I ask you which is greater. We have 3/4 and 3/5. Now, based on what we learned yesterday, if the numerators are the same, which they are, we can look at the denominators and decide which is greater. But you know how I am. I like to give you guys lots of options for how to solve problems. So I'm going to show you another way today that I want you to try and to practice. We're going to draw an area model, 1 for each fraction. Now we need to make sure that our area models are about the same size again, because we want to be comparing the same size whole. I can't compare a small pizza and a large pizza and pretend the pieces are the same. They're not. So I have 2 area models. Again, not perfect, but I did my best. I'm going to divide this first one into 4ths, and I'm going to draw the lines vertically or up and down. And then I'm going to color in 3 of those 4ths. Boom, 3/4. Then this one, I'm going to divide it up into 5ths, but I'm going to draw my lines horizontally or side to side. 4 lines makes 5ths, and then I need to color in 3 of them. Now again, you probably already know which one's bigger if you followed along with the lesson yesterday. That's an even better reason to try this new method, because then we'll know if we did it correctly or not. Now remember when we were finding equivalent fractions and we partitioned or divided our fraction models another way. So like these are vertical and then we did it horizontal. It was magical. It's just math, but math is magic. Today we're going to do the same thing, but we're going to use that method to compare. So I'm going to take this area model and divide it into 5ths with vertical lines, like so. And I'm going to take this area model and divide it into 4ths with vertical lines. Whoops, the last one was horizontal. I think I said vertical. You know what I meant, hopefully. So that each one has lines going vertically and horizontally. Now, if I did this correctly, there should be the same amount of pieces in each hole. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Got 20 here. And let's check this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, 20. Whew, I did it right. There's 20 there too. So they're both divided up into 20 pieces. That means both of them are now 20ths. And we just need to figure out which one is more. Now, hopefully, you already know which one is more, so we can make sure this method works. Let's count how many we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 3/4 is the same as 15 20ths. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. And 3/5 is the same as 12 20ths. So that means 15 20ths is greater than 12, because we know 15 is more than 12. Now that our denominator is the same, we just look at how many are colored in, which means, back to our original fractions, 3/4 is greater than 3/5, which does go along with what we learned last time. Fourths would be bigger pieces than fifths, so 3/4 would be greater than 3/5. Okay, now I want you to try this method. I want you to try solving them like this, with drawing the area models. On page 107 in your Learn book, looks like this. If you were able to come to the school and get your packet, it's in there, page 107. There's 6 problems. I want you to try them. If you need to download it, you can download it from the assignment in Google Classroom. The first 2, they did part of the problem for you. They started drawing your area models, but I want you to try all 6 and then come back and watch the next part of the lesson. So try all of page 107 first and then watch the next video.